day, everyone. Today we'll talk about ligands. What are ligands? The most sweetest part of this particular ligand is they are cheerful givers. They donate. The question you should ask yourself is, are you a ligand? If you want to know what this ligand is all about. Ligands are atoms or molecules or group of atoms. Take note of this word: atoms, molecules, group of atoms. They can be in group that donate pairs of electron to a metal ion. Now, these are the words that we need to take note: pairs and metal ion. You need to take note that ligand donates in pair. What do we mean by pair? Two at a time. That is, if I have, let me use this analogy. If I have this man, the ability to donate these two is what we call ligand. Example of what you can get in pair is a pair of shoe, a pair of slippers. Now, since ligands can donate, then we can also say they are Lewis base. How are ligands Lewis base? This is because Lewis base are also electron donor, and ligands are what? They donate pair or pairs of electron. But you need to take note of this: all ligands are Lewis base, but Lewis base may not be ligand. How? This is because ligands donate pairs of electron, while Lewis base only donates electrons. It can donate 1, 2, 3, but this will always be in pair, 2 at a time. If a ligand is donating 2 electrons, that means it is donating 4. But for a base, it can just donate 2 unpaired electrons. It can decide to donate unpaired electrons, can decide to donate paired electrons. The ligands will only donate pair of electron. To explain Lewis base better, let us recall the dissociation of water. For the dissociation of water, Arrhenius acid says acids are substances that donate hydrogen proton when dissolved in water. Therefore, our H plus is acid, while our OH is a base. We can also remember the charge of an electron. For charge of an electron, charge of an electron is negative. You can say this is electron deficient, while this is electron rich, because it possesses the charge of an electron. And Lewis base, they are electron donor. So this is our Lewis base, while the other way around is our Lewis acid. I think we now get that. For Lewis base, they can donate unpaired electron, but for a ligand will donate pair of electron. Let's go to the next section: classification of ligands. Ligands can be classified in 2 ways. The first one is based on dentation, while the other is based on charge. Dentation. The dentation of a ligand is the number of coordinate covalent bond or donor group in a single ligand. Just a ligand, that means in their donor group or their covalent bond. Why that of charge? A charge is an electronic charge which may be positive or negative. For the classification of ligands based on dentation, we can have monodentates, bidentates, polydentates, ambidentates, and flexidentates. Let us now look into each dentate one after the other. Let's talk about this monodentate. This is a compound word that contains mono. Mono means one. While dentate is the donor group of a ligand. We can therefore say for monodentate, monodentate has just one donor group. These are ligands that has one donor group for bonding. Examples are, we have the hydroxyl OH, chlorine, ammonia, and water. For the word bi means two. Then we have bidentate as ligand having two donor sites. That is, it can donate two pairs of electron. Example include ethylene diamine. Another example is oxalates, oxalate ion, which is C2O4 2 minus and more. Now for the word poly, poly means more than two. Under this poly, we can decide to have tridentates, tetradentates, pentadentates, hexadentates. Everything is still under polydentates. These tridentates, we have learned ethylene diamine. We can decide to increase the two molecules in ethylene diamine by one. That is, we will have diethylene triamine. Diethylene triamine becomes a tridentate. Then for tetradentates, we can still increase this by one and this by one. The di becomes tri, ethylene, tri becomes tetraamine. For pentadentates, the tri increases to tetraethylene, pentaamine, and so on. Another example of polydentate is EDTA, which is known as ethylene diamine tetraacetic acid. E structure. How do we draw the structure of this EDTA? From that word ethylene first. Take note that ethylene is just CH2, CH2. Then we have our diamine. For the tetraacetic acid, acetic means acid with two carbon, that is acetic acid. The hydrogen from ethylene diamine has been replaced by acetic acid, which is CH3COO minus CH3COOH So this is the formula for ethylene diamine tetraacetic acid. For the word ambidentate, they have two donor groups but can only be coordinated to a metal by one donor atom. We need to take note of that. These are the kind of, let me use an analogy by saying some people, they can have two things, but they find it difficult to give away the two because they will feel like if they lose the two, they have nothing left. So they decide to give one and have one with them. Those kind of people, you can use that word ambidentate for them. So ambidentates are ligands with two donor groups but can only be coordinated to metal by one donor group. For example, we have NO2. NO2 can get coordinated to metal through the nitrogen or through the oxygen. But the two donor group is nitrogen and oxygen. But it can only get coordinated to each of them to the melter through nitrogen or through oxygen. Another example is the thiocyanide. For thiocyanide, it has two donor groups, one on sulfur, the other on nitrogen. But it is either the sulfur is bonding to metal or nitrogen bonding to metal. These are examples of ambidentates. For flexidentates, flexidentates are just like ambidentates, but they are polydentate ligands. How? You would remember that ambidentate has two donor sides but can only donate one pair of electrons. For flexidentates are polydentate ligands that can donate one or two or three, but they don't donate all they have as a donor group. So therefore, flexidentates are polydentate ligands that do not get coordinated to metal ions through all their donor sites. Example is EDTA. EDTA has 4 donor sites, but it prefers getting coordinated to metal ion through 2 sites. This is a perfect example of flexidentates. Now let us consider the classification of ligands based on charge. For the classification based on charge, we can only have the neutral ligand and the anionic ligand. Take note, we cannot have cationic ligand because ligands are electron rich. So therefore, we can only have the neutral ligands and anionic ligands. For the neutral ligands, they possess no charge. Example is H2O, NH3. And for the anionic ligands, they possess negative charge. Example are cyanide, OH minus, SO42 minus, and so on and so forth. So in the next class, we will consider how to name the neutral ligands and the anionic ligands, which will lead us to naming of coordinate compound. I hope you enjoy the class. For more topics on chemistry and other subjects, don't forget to subscribe to Tutor Henry Messi.